am David Esparza, co-founder and CTO of Hyphae Composites.
And I am Adriana Esparza, sister, co-founder, and CEO of Hyphae Composites. Oh, actually not yet. There is a practical reason to be here, and there is a personal one too. Hyphae doesn't ask which one got you here, it was built for both. Starting off with Hyphae's why, let's talk about what keeps our country up and running: manufacturing. On the screen, you can see a simulator. This is a Tier 2 manufacturing facility that makes car housings from ABS, which is a common plastic type. Starting from the top left, we selected 12 machines for this medium-sized facility. We are considering extruders for this, but this can also be applied to injection molding machines and industrial-sized 3D printers. If each machine makes the average percentage of scrap, let's say 8%, but this could be a wide range, we get to the facility losing over $1.5 million per year, only counting for material value. Here in the amazing Michigan is the third plastic part producer workforce in the country. So there are at least 800 facilities where we could apply a scrap scenario like this one. Now, if you found this problem familiar, I have a question for you. How will you and your engineering teams use the $1 million if this problem was solved? The post-industry scrap problem is a complex one to solve, and the options that are available right now don't bring any value to the manufacturers themselves. So after spending the last few years in cheminformatics and entrepreneurship, I got my inspiration from different processes in nature, all at the molecular level. David, co-founder, he has spent the last decade at manufacturing facilities where he not only identified the problem, but the complexity that surrounds it. So right now, together along with other great scientists, engineers, and mentors, we're creating a solution for post-industry scrap that doesn't add any more weight to the sectors that we serve. Tariffs, oil prices, and energy mandates are already putting way too much pressure on them. So our solution has 3 components, and it's a system that brings industrial plastic scrap back into the production line. On the top, you can see the summary flow. The first component is the hardware, which is a compact and autonomous unit that has a provisional patent on it, and that can take scrap to pellet. It also encapsulates the other 2 components. The second component is the master batch. So each formulation has been developed by the guidance of international polymer chemists, and they recover the essence of the polymer. The third component is the machine learning layer. This one is currently trained on public polymer databases and is designed so in the future it can be paired with inline infrared spectroscopy so we can QC every batch, collect and store data. That way we will not only provide insight to our customers about their polymer scrap, but it will also allow us to refine every master batch as we go. Every layer is independently defensible, and they are what makes our IP a system and not just a machine. We created our business model so we bring CapEx down to 0 for our customer, and so that the financial value is high enough to cover for Hyphae's cost. That way, the engineering teams can keep their million, and we don't send any useful material to the landfill. Today, we're looking for partners to help us take our technology outside of the lab and into industry. So if you are an investor, you could be a capital provider, and we are offering equity plus a gross margin when revenue generating. Or if you are at a manufacturing facility and see benefit in us, you can get to host one of our first pilots and get your preferred price locked in. Or if you believe you could be a connector, one meaningful introduction from you could help us get the right partner first. We look forward to connecting with you after this or via email or LinkedIn. Thank you.